Alright, so write it as a single logarithm. Well, I guess you could argue, hey, it's already a single logarithm. But what they're wanting you to do is to take that 1/2, make it an exponent, log base 2, 25c squared to the 1/2. But what's 1/2 as an exponent the same thing as? Not negative. Negative flips it over. What's a fraction do? A square root. Good. Power. The top number's the power. The bottom number's the root. The root grows on the bottom. So, log base 2 of the square root of 25c squared. And then what do you know? Both of those have a square root. So, log base 2 of 5c.
How many points would have been taken off if I stopped at the log base 2 the other one?
At this one? If it's a 5-point problem, probably 2 off.
Oh my goodness.
Yeah.
Better not mess that one up.
Other questions from worksheet 5? Do we need to do one of the expands, or is it all straightforward enough? Let's do one of the expands, just so if only the folks at home can have something to watch. Let's do number 5, because that one looks crazy. By the time you got to 5, I bet you were just jumping to the final answer. Like, you don't need to write 3 steps on these. Right? Anything in the top is going to be positive. Anything in the bottom is going to be negative. And any exponent is going to come out front. So, log base 3 of 3 plus 2 log base 3 of x plus 3 log base 3 of z. So there's the top. Not done yet, but there's the top part, expanded. The bottom will subtract, so minus log base 3 of 10 minus 4 log base 3 of y minus log base 3 of w. So kind of annoying to have to write it all out, but not very difficult. And I suspect most of you will soon get to the place where you can do what I just did, and that's just jump to the final answer. Anything multiplied in the argument ends up being added as separate logs. Anything divided in the argument ends up being subtracted as separate logs. And then, of course, the exponents come down front.